In this video, we're going to start taking a look at two samples and doing hypothesis tests when we deal with two samples. To do that, we're first going to take a look at doing a hypothesis test when we are dealing with two different proportions. So when comparing two population proportions, the null hypothesis is that those proportions are equal, right? And so our null hypothesis is going to be that P1 is equal to P2, right? So the proportion of population 1 is equal to the proportion of population 2. The alternative hypothesis could be one of the three following items. It could be that your first proportion is not equal to the second proportion, right? So P1 is not equal to P2 in some manner. It could be that your first proportion is actually bigger than the second, or that the first proportion is actually smaller than the second. Right? So we could have any one of those items as our alternative hypothesis. Notationally, we will split our population. We'll think about these two different populations or two different groups. So P1 is the proportion, the population proportion for population 1. P1 hat is that sample proportion. P2 is population 2 proportion. And P2 hat is sample 2 proportion. Then we have the associated sample sizes and number of successes. We also pool our data when we go through this process. And so that pooled sample proportion, that is on top all of the successes from the two combined. So x1 plus x2. And on bottom, we have all of the trials, both of the sample sizes from the two samples combined. And then for each one of those p's, each one of those proportions, we could take the complement of those, and so we could find these values of q. So we could have q, the complement of the pooled sample, q bar, q1, q2, q1 hat, and q2 hat being the complements of those values up here as well. Our test statistic for this hypothesis test is going to be a z-statistic. So this deals with a normal distribution here. And the way that z-statistic is calculated is it's going to take the proportion from sample 1 and subtract from it the proportion from sample 2. It then divides by the square root of the sum of the pooled sample times its complement over sample size 1 plus the pool sample times its complement over sample size 2. We create a confidence interval. This confidence interval is a little bit different. It is a confidence interval for the difference of those two proportions. And so when we have 0 in that confidence interval, 0 in the confidence interval means that it is reasonable to believe that P1 minus P2 is equal to 0. Right? And so if you were to add P1 to both P2 to both sides, you end up with P1 is equal to P2. So what this means for us is when we see 0 as in that confidence interval, that says those two values, those two proportions could be equal. If it was all positive values, then we would be saying that P1 looks to be, or appears to be, larger than P2. If we had all negative values, then we would say it looks like P2 is larger than P1. We can use StatDisk to do this, and so here are those steps to roll through StatDisk to do a hypothesis test about two proportions. And we'll do this here in a moment. When we think about associating hypothesis tests with our confidence intervals, for a two-tailed test, a hypothesis test with a significance level of alpha, so this is for a two-tailed test, that is associated with a 1 minus alpha % confidence level. And so if we have a two-tailed hypothesis test with a 10% significance level, 0.1 significance level, then 1 minus 0.1 is 0.9. That gives us a 90% confidence interval. So a two-tailed test with a 10% significance level has a 90% confidence interval associated with it. If we have, instead of a one-tailed test, two-tailed test, if we have a one-tailed test instead, here that value significance level of alpha is associated with a 1 minus 2 alpha confidence interval. So if we have a significance level of 0.1, we're going to take 1 minus 2 times 0.1, which is 0.8, and as a percent, we end up with 80% for our confidence interval. So make sure you're aware of those things when you are thinking about what confidence interval is associated with a particular significance, particular hypothesis test. One-tailed tests, we need to take 1 minus 2 times the significance level to find the associated confidence interval. And two-tailed tests, we just take 1 minus that significance level. We talked about this a little bit on the previous page, but how do we interpret an associated confidence interval for these? So if our confidence interval contains 1, if it contains 0, it is reasonable to believe that the two proportions are equal. In terms of a hypothesis test, we would fail to reject the null. If instead we have a confidence interval and it contains only values greater than 0, then we would say there's evidence that the first proportion is greater, or we might say that there's evidence that the two proportions are not equal, and specifically the way they appear to be not equal is the first proportion appears to be greater. And if it's only negative values, only values less than 0, then the first proportion appears to be smaller than the second. All right, so that is hypothesis tests for two samples dealing with proportions. In the next video, we will look at an example where we will go through some stat disk with it.